Hey everyone, so today we're going to be doing monohybrid mice. So for the directions, solve each problem showing your work in the Punnett square. For each cross, give the genotypes and phenotypes of the offspring and the probability of getting each. List these in the table seen by each problem. Answer the questions that accompany each problem. So we're going to be given different scenarios and we're just going to be answering some questions based on the Punnett square and the probabilities we find. So what do we need to know about these special mice? In laboratory mice, the gray coat color is dominant over albino coat color. Remember, albino does not mean white. That means it does not have any pigment, but it kind of has a white kind of color to it. But an actual albino animal, even their pupils will be kind of a red tint. But if you have, like, let's say a mouse of your own that is white, that's the color of its coat. It's not albino. So for the first problem, we're crossing a female that is heterozygous or big little with, I'm going to put my X on with, a male that is homozygous recessive, little. So the female came first. I'm going to put that one on top for the genotype. For the male came second. I'm going to put it on the side. So here we go. Big little, little. Now we do our matching. Big little, little. Big little, little. So before we answer all of our questions, let's go ahead and write our genotypes and our phenotypes like we have done in the past. For genotypes, you do big, big little, and little. For phenotypes, the gray color coat is dominant. The albino color coat is recessive. So looking at our Punnett square, we have 0% big. None of the squares have that genotype or that combination. For big little, 2 out of the 4 squares have that. So that would be the same thing as 2 fours, 1/2, or 50%. Also, for homozygous recessive, little, we have 2 out of the 4 squares. That one would be 50%. So, looking at our phenotypes, if it has at least one capital letter, I'm going to shade it in. So you can look at our genotypes. 0 plus 50 would be 50. Or you can look at our Punnett square. Sure enough, you get 2 out of 4, which is 50. So this one is 50% gray to albino. So let's go through these questions and see if we can answer them. Number 1, what is the probability of getting gray offspring? Well, we have 1/2, or you could do 50%. Some of you might want to leave it 2 fours, and that's fine as well. What is the probability of getting albino offspring? Well, we found that to be the same, 1/2 or 50%. So number 3, how many possible genotypes are there among the offspring? Well, there was 0% for big. So we do have a value for these 2. So there's only 2 possible genotypes given. How many possible phenotypes? Well, we have a percentage for gray and we have a percentage for albino. So we have two possible phenotypes for the offspring. Number 5, what is the probability of getting heterozygous offspring? Well, remember, hetero means different or big little, and that goes with big little here, so 50%. Homozygous, remember, means same, and that can either be big, big, or little, little. So we had 0% for big, big, but we had 50% for little, little. So this one is also 50%. Number 7, what color is the female? Well, the female, if you remember back from your problem, is big, little. Since you have that dominant trait appearing, she is going to be gray. What color is the male? Well, the male is little, little. So he has the recessive trait, which is albino. All right, let's go to the next problem. So now we're going to do a cross between a homozygous gray female with a heterozygous male. Homozygous, remember, means same. She is gray, so that is the dominant trait. So, since it's same, we're going to do big, big using the letter G, and that would go on top because she was first in the word problem. For the male, we have heterozygous. Remember, that means different or big, little. So that'll be big G, little g. And this one's going to go on the side. So let's now do our Punnett square. Big, big. Big, little. Now let's match them up. Big, big. Big, big. Big, little. Big, little. Remember, for genotypes, you write all the possibilities using that letter. Big, big. Big, little. Little, little. Looking at our Punnett square, 2 of the squares have big, big. So that would be 2 out of 4 or 50%. Big, little, we have 2 out of 4, which is 50%. None of them have little, little. That one would be 0%. For phenotypes, our dominant trait is gray. Albino is our recessive. So I'm going to shade in the dominant trait. It has to have at least one capital allele. This one has 2. This one has 2. This one has 1. This one has 1. So that is 4 out of 4 or 100% gray, 0% albino. So let's answer these questions. Number 1, what is the probability of getting gray offspring? That one was 100% from our phenotypes. Number 2, what is the probability of getting albino offspring? That was 0% from our phenotypes. How many possible genotypes are there among the offspring? Well, we had information about big, big, We had information about big little, but we didn't have any for little little or homozygous recessive. So we had 2 out of the 3, so 2 possibilities. How many of the possible phenotypes are there among the offspring? Well, since we had 100% gray, we have 0% for albino. So there's only one possible phenotype for these offspring or for the babies. What is the probability of getting heterozygous offspring? Remember, hetero is different, so big little, and that is 50%. Or you could have said a half. Either way is fine. Number 6, what is the probability of getting homozygous offspring? Remember, homozygous means same, and that's either big, big or little, little. So big, big, we had 50. For little, little, we had 0. So 50 plus 0 is 50. So you had 50% or a half. What is the genotype of the female? Well, that's what we got up here from the original. So that would be big, big or homozygous dominant. What color is the male? Well, since he is heterozygous, he still has that capital allele or that dominant trait is apparent. So he is gray. All right, now we're going to do the next problem. All right, the third problem is you're crossing a gray female whose father was albino. So here's the thing. Remember, if you're gray, that has to have at least one dominant allele. So this could either be big, big or big, little. The key here, her father was albino. So she can be a carrier of that trait. So remember, albino was the recessive. So since we have to apply that to her, she is actually going to be heterozygous, big, little. And we're going to cross her with a heterozygous male. So she's going to go on the top. He's going to go on the side because he came second. Hetero, remember, means different, big, little. So big G, little g. All right, now let's put him on our Punnett square. Big, little, big, little. Now we match them up. Big, 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 little, big, little, little, little. Genotypes, remember we list all the possibilities using whatever letter they give us. Big, big, homozygous dominant. Big, little, heterozygous. Little, little, homozygous recessive. So for big, big, we have 1 out of the 4 squares. So 1/4 is the same thing as a quarter or 25%. For heterozygous, we have 2 out of the 4 squares. So that's going to be 50%. We're left with little, little. We have 1 out of the 4 squares. So that would be 25%. Phenotypes. You have gray, remember, is the dominant trait. Albino is the recessive. So we're going to shade in the dominant. Has to have at least one allele that is dominant or capitalized. So 25 50 is 75%. Albino would be 25%. But let's double check with our Punnett square. We have 2 capital letters, one capital letter, one capital, or dominant allele, and then recessive. So 3/4 is the same thing as 75%. All right, let's look at our questions. Number 1, what is the probability of getting a gray offspring? Well, 75%, or you could have wrote 3/4. Either or. Number 2, what is the probability of getting an albino offspring? Well, that was 1/4 of the squares, or you could have said 25%. Number 3, how many possible genotypes are among the offspring? Well, we have a value for each of the possible genotypes. So there's 3 possibilities. How many possible phenotypes are there among the offspring? Well, both of our phenotypes have a value. So yet again, you have 2 possibilities. Number 5, what is the probability of getting heterozygous offspring? Remember, heterozygous means big little. So that was 50%. What is the probability of getting homozygous offspring? Remember, that can either be big, big or little, little. So for big, big, we had 25%. For little, little, we had 25%. When you add those together, you get 50%. All right, number 7. What is the genotype of the female and how do you know? What is the genotype of the female? Well, we figured out she's already gray, but for genotype, that is the 2-letter combination. We came up with big little because she's a carrier of the albino gene since her father was albino. So she was big little for genotype, which is the 2-letter combination. And you could write she's dominant in coat color and carrier of albino trait. Number 8. What is the genotype of the male? Well, he is heterozygous. We know that is big little. So capital G, lowercase g. And we know that because he is strictly heterozygous. All right, last problem, y'all. We're now going to do a cross between an albino female whose father was gray. Now, key thing here, since the female has to be albino, it has to have homozygous recessive. That's the only way any of these little critters can be albino. Now, this is not important information in this word problem that her father's gray because she is both having the alleles of recessive. So her father is probably going to be big little, but that's not who we're crossing her with. So this actually is not important information right this moment. So we're crossing her with a gray male whose mother was albino. Now, remember for gray, we can either do big, big or big, little. The key thing is here, his mother was albino, so he carries that trait. So for him, he is going to be heterozygous. So big, little. So she came first. We're going to put her on top. We're going to put him on the side. All right, let's match up our Punnett square. So little, little for the female, big, little for the male. Match them up inside. We have big, little. Big, little. We always write the dominant out front. Little, 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 little. We always write all the possible genotypes. So big, big is 0%. Big, little, we have 2 out of the 4. So 50%. Little, little, we have 2 out of the 4. That one's also 50%. For phenotypes, gray is the dominant. Albino is recessive. So I'm going to shade in the dominant. So 0 plus 50 is 50. So remember, if that's 50, albino will be 50%. Judging by our Punnett square, we could also shade in this way. We have 1 dominant present, which still counts, and here we have another one. So 2 out of 4, 50%. So let's now answer our questions. Number 1, what is the probability of getting gray offspring? Well, we found 50%. If you wrote 1/2 or 2/4, it's the same answer. Number 2, what is the probability of getting albino for offspring? We have 50%. You could have also written 1/2 or 2/4. Number 3, how many possible genotypes are there among the offspring? Well, we have none for the genotype of homozygous dominant, but we do have values for the other 2 possibilities. So we have 2 possible genotypes. For phenotypes, for number 4, how many possible phenotypes are there among the offspring? We have information or probabilities for both gray and albino, so we have 2 possibilities. And number 5, what are the probability of getting heterozygous? Remember, hetero is big, little for different, and that was 50%, big, little. What is the probability of getting homozygous offspring? Well, remember, homozygous means same. So it's either big, big, we had 0%, or little, little, we had 50%. So 0 plus 50 is 50%. So number 7, what was the genotype of the father of the albino female? All right, so now we're going to use that information. So his daughter, remember, was little, little, the albino, but the father was gray. Well, in order for him to either be gray, he has to either be dominant, dominant, or dominant recessive, big, little, since he was gray. But since he produced an albino offspring, he has to carry that allele. So he has to carry that recessive albino trait. So he has to be heterozygous. So big, little, heterozygous. All right, y'all. Hopefully you did well on monohybrid mice.